Now we're starting to get into a new chapter, chapter 4, which deals with what we call indefinite integration, also known as antiderivative. And the name antiderivative is a really good way of describing what this is all about. This is basically going backwards, starting with the derivative and going back to the original function value. Okay? So all the rules that you may remember about going from a function to a derivative, you go through your mind going backwards is what integration is going to do. So it's like algebra. Algebra is actually basic mathematics done backwards. In other words, we know that the rules of numbers are you do exponents with and parentheses, do parentheses first, then exponents, multiplication and division because they're the same thing, and then addition and subtraction because they're the same thing. But in algebra, it's exactly the opposite. You do the addition, subtraction first, then the multiplication, division, and then the exponent, and then the parentheses. It's the same thing. We're just doing backwards. So you may be going, oh my word, how am I going to remember this after I barely got through the first 3 chapters? Well, on page 250 and on the front flap of your textbook, you have a list of various antiderivative or integrations. Now, the one thing I want to point out to you is the word indefinite. While we're able to come up with definite values for derivatives, we are not with integration because of the fact that you're going to have some number that was added or subtracted within the function by itself that cannot be accounted for. So we use a C for constant, English constant, to show that representation. We can't really solve for it. There's nothing we can do about it, but we know it's there. So there's a few examples I'm going to show you here, then we'll do some example problems. Let's suppose that we have a derivative of 5x. And we know that we have a 1 here. 1 minus 1 is 0. And then the 1 we subtract is multiplied by 5. And that gives us 5 by itself. The opposite of that is if we were to take the 5, and say you want the integration of the 5 dx, the resultant derivative, we want to go back to the function. Then we do the opposite. In other words, we know here that there is no x, and so the x here has a 0 exponent to begin with. And we have a denominator 1. I'm sorry, we don't have a denominator. Well, we do have a denominator 1. But what's going to happen here is that we are going to add 1 to the exponent, and then we're going to divide the denominator by this quantity right here. This had no denominator per se, or did have 1, and so in effect, then this 1 that was the denominator is multiplying this combination right here. So this combination and the exponent goes down here, kind of going backwards, and then it's going to multiply by the original denominator, which is 1, and that gives us 5x to the first power, which is 5x, plus that unknown number, the indefinite number, the uncertain number, c. Okay? Now, we could have also expressed this as this. If we're trying to find the derivative of 5 dx, we bring the 5 out and just do the work on the dx, and we know that dx is going to have the same thing. If it was the derivative of x, that means we started with x. Okay? Let's take this example right here. We have, in the original derivation problem, we're finding the derivative of x to the 4th. Well, what did we do? We subtracted 1 from the 4 and put the 4 over here. Subtracted 1 from the exponent to give us 4x cubed for our answer. So the derivative of x to the 4th is 4x cubed. However, if we go backwards on this, start with the derivative of this, and it should have a dx after that. They have habits all over the place. Or x cubed dx, then what that is telling us then, we're going to put a 4 on the outside, and we're going to focus on the x cubed dx. Now, if we look at the x cubed, we know that if it's going to go backwards, instead of losing 1, it's going to gain 1. So we're going to gain plus 1 here, which means the denominator over here is 3 plus 1. It's going to be 3 plus 1 times the 1 denominator we have right here. And so that gives us 4. 4 divided by 4 is 1. 3 plus 1 is 4. So the answer is x to the 4th plus c. Okay, so it's a backwards manipulation like algebra. So let's take a look at some practice problems. Let's open up our books to page 250. Or 255 rather, sorry. Now let's take a look at problem number 27. Alright, so I'm going to break this down to 2x minus the derivative of 3x squared. And dx of each one of these. Okay, now we can bring the 2 on the outside or the 3 on the outside, or just leave it there. I'm going to leave it there. I'm not going to bring it out. That's just an extra step that really is not necessary, but if you want to do it, that's fine. But the thing to remember here now is that this is a 1, and it was a 2 before it became a 1. So we have to add 1 here and put 1 plus 1 here. And this was a 3 before it became a 2. So we're going to divide this by 2 plus 1. And so 2 times x to the second power divided by 2. 2 divided by 2 is 1. So that gives us x squared. 3 divided by 3 is 1. So that's the minus x cubed. And then our indefinite value that we don't know the answer to what that is c. And that is your answer. Number 21, do the same thing, separate it out. So this becomes the integration of x to the 3 halves dx plus the integration of 2x dx plus the integration of 1 dx. Okay, so let's go through the changes here. We know that this is going to be 1 larger. And so we're going to divide by that 3 halves plus 1 down here. This is 1 plus 1 here. That means we're going to divide by 1 plus 1 here. And remember, if there's no x there, that is actually x to the 0 power. Okay? Important to remember that. And that means we're going to add 1 there. We're going to divide by that 0 plus 1 right here. And so when this is done, now this is 5 halves, so that becomes x to the 5 halves, or I'm sorry, x to the 5 halves divided by 5 halves. We'll come back to that. That's what we've got right now. Plus 2x squared divided by 2, so that just becomes x squared. And this becomes x to the first power over 1 times 1, which is just x plus c. Now, we got this thing here, so what we need to do is resolve this. When you divide by 5 halves, it's the same as multiplying by 2/5. So this becomes 2x to the 5 halves over 5 plus x squared plus x plus c. And there's your answer for number 21. Number 25. To do this problem, I'm going to rewrite this as x to the negative 3 power. So this becomes the derivative of x to the negative 3 power dx. And we'll go through the same thing here. We're going to add 1 here. And divide by negative 3 plus 1. So this becomes then x to the negative 2 over negative 2 and then plus c. And then we're going to move this to the denominator. So this becomes negative 1 over 2x squared plus c. Not too bad, right? It really isn't too bad. It's just kind of mind-blowing the first time you deal with this, but once you get the pattern down, and I never taught myself this in high school. This came later on. And I tell you what, it's a good way to do this. I don't think it's even shown in the book specifically this way. They mean it, but I'm not sure how well they can say it. So use this process. It helps. Number 29. Okay, so what we're going to have to do here is we're going to have to go ahead and multiply this thing out. If you FOIL this thing out, you get 3x squared plus x minus 2 dx. It's just dx. So we're going to break it down into its parts. And we don't necessarily have to do show the derivative for each one. We know that's what we do. I just did that for introduction purposes. Once you do it enough times, you're not going to want to do it. So we're going to add 1 here, divided by that 2 plus 1. Alright, so you're going to add 1 here, this is 1 to begin with, plus 1 and divide by 1 plus 1. And this is 2x to the 0. Plus 1 divided by 0 plus 1. So, this gives us 3 over 3, which is 1, so that's x cubed. This becomes x squared over 2 plus 2 times x to the first power over 1 is just going to 2x plus c. Okay? Alright. And, yeah, I think we'll just leave it right there. So your assignment here on page 255, 18, 22, 26, 30, and 34. Have fun!